So, good morning, students. So, welcome to the online class. So, in this video, we will study the antimicrobials, that is, antimicrobial agents, with a special emphasis on the inorganic antimicrobial agents. So, this session we will cover the definition, classification, mechanism of action, and important examples commonly asked in the pharmacy examinations. So, we already discussed what is antimicrobials, right? So, antimicrobials are drugs which destroy the microorganisms. So, these are classified into two types. One is antiseptic and another one is disinfectant. So, what is antiseptic? It is a chemical substance which, when applied on living tissues, inhibit the growth or destroy microorganisms without causing significant damage to the tissues. So the antiseptics will kill the microorganism on living things. So examples: hydrogen peroxide, boric acid, iodine, and iodine preparations, weak iodine solution, strong iodine solution, povidone iodine, etc. So we are using as an antiseptic. What is disinfectant? A disinfection is a chemical agent used on non-living objects to destroy or eliminate microorganisms, but it will not kill the bacterial spores. It will be used on inanimate objects, right? So examples: chlorinated lime, phenol, potassium permanganate, etc. So the mechanism is important. The inorganic antimicrobial agents act mainly through the following three mechanisms. One is oxidation, another one is halogenation, and protein binding or protein precipitation. There are so many compounds given in our syllabus. One is hydrogen peroxide, another one is bleaching powder. For these two compounds, we have to study the preparation, assay, properties, and uses. The other compounds, remaining compounds, iodine, potassium permanganate, boric acid, and iodine preparations like povidone iodine, strong iodine solution, weak iodine solution. We have to study only the preparation, property, and uses. Right? So we'll see the first compound, hydrogen peroxide, that we have discussed in the morning session also. So we'll repeat once again for the easy understanding. So this hydrogen peroxide, the formula is H2O2, just one oxygen extra in water, H2O, one oxygen extra, H2O2. So this is prepared from barium peroxide in non-electrolytic method. So barium peroxide is slowly added to the dilute cold sulfuric acid. So it is very, very important. The temperature is very important. The temperature should be less than 40 degree. So we will get barium sulfate precipitate and H2O2, hydrogen peroxide. The barium sulfate precipitate is removed by filtration. So in the electrolytic method, the sulfuric acid is first oxidized. We will get peroxide disulfuric acid, which is further hydrolyzed to give sulfuric acid, right? Peroxide disulfuric acid is hydrolyzed, will get peroxide sulfuric acid. Then further hydrolysis of peroxide sulfuric acid, we will get hydrogen peroxide. So very, very important, the assay. So you know the hydrogen peroxide has both oxidizing and reducing property. This may be assayed by redox titration, that is oxidation reduction titration. So here the solution, the hydrogen peroxide solution is acidified with dilute sulfuric acid and titrated against potassium permanganate. Potassium permanganate itself acts as a self-indicator. The endpoint is the appearance of permanent pale pink color. Clear? So potassium permanganate is a titrant in redox permanometry titration. So it should be taken in the burette. In the conical flask, we should take hydrogen peroxide and that should be acidified with sulfuric acid. So during titration, we will get a permanent pale pink color. We have to stop the titration and calculate its percentage purity or the amount present based on the titer value. Right, clear? So coming to the physical properties, so we know it is a colorless liquid. It has a slight acidic taste. So it will decompose rapidly in alkaline solution under catalytic influences such as copper, iron, manganese. It will be easily decomposed. So it will decompose into water and oxygen. So the hydrogen peroxide should be stored in a well closed container, tightly closed container. You should not use any metal containers. You should use either glass or plastic container to store the hydrogen peroxide. Clear? So it is used as an antiseptic and topical anti-infective. So mainly this hydrogen peroxide solution is used to clean the wounds where the pus is found, and also it is used to clean ears. So the wax in the ear is removed by using hydrogen peroxide. Clear? So hydrogen peroxide is a very important compound, inorganic compound, which has antiseptic and topical anti-infective property. So it is mainly used to clean wounds, ears where the pus is present. So assay is very important. So this is assayed by redox titration. You know, you might have studied many type of titrations in the pharmaceutical analysis, like acid-base titration, non-aqueous titration, complexometric titration, precipitation titration, etc. So here in redox titration, we have different types of redox titration, right? Permanometric titration if KMNO4 used as a titrant, iodometric titration if iodine is used as a titrant, iodometric titration if sodium thiosulfate is used as a titrant, if seriometry if steric ammonium is used as a titrant, right? So many type of redox titrations. So in that, this is assayed by permanometric titrations. Clear, students? If you have any doubt in this, please ask. Right? So thank you. This is the very important topic that we discussed. So we'll see the next compound bleaching powder in the next slide. Please stay in the online. I will open the other slide. Thank you.